Welcome to part 4 in the Claude Code day-by-day series. You ask Claude Code to implement OAuth. It starts strong. 3 hours later, the code is half finished.
You start a complex feature build with an AI coding assistant. Hour 1 is highly productive. By hour 3, the agent is writing looping error messages and hallucinating functions it deleted 40 minutes ago. The underlying issue is degradation of context. The model forgets original acceptance criteria and wanders down conversational detours that pollute the active workspace. To force the agent back on track, engineers usually reach for an overlay. They bolt on a heavy project management plugin or nag the model every 5 turns to update a single TODO.md file. This creates a structural bottleneck known as the single tracker fallacy. Forcing one monolithic file to handle planning, live execution, and storage simultaneously creates fatal context bloat. The fix is architectural state separation. Claude natively isolates 4 layers: plan mode, Spec-Driven, a live task list, and a todos.json mirror. Protecting the LLM's context window from collapsing requires utilizing these isolated layers. Handling ambiguous feature requirements happens entirely before you allow the model to write code. You start this with the interview-to-spec workflow. Inside a fresh session, you instruct Claude to run its native Ask User question tool against your rough idea. Instead of guessing your intent, this tool forces the model to interrogate you. It extracts answers regarding edge cases, like whether a token refresh failure should retry silently or fail loudly. The output of this interrogation is a static, frozen file written to disk, named feature.md. It clearly defines the problem, the required goals, non-goals, and explicitly rejected alternatives. Once that file is generated, engineers routinely make an operational mistake. They ask the LLM to begin coding immediately. That conversational history is pure exploration noise. The detours and rejected ideas become dead weight. When execution begins, this noise actively confuses the LLM's attention mechanism. You resolve this through context cleansing. Commit the spec to disk, then execute a clear command to purge the entire conversational history from memory. You then launch a fresh session that reads only the committed spec, creating a hyper-focused environment strictly for building. Establishing this strict boundary between research and execution ensures you never drag conversational bloat into the active codebase. With a cleared session, the agent begins execution. The immediate question is how it tracks its progress without maintaining a text-based to-do list. The primary technical limitation dictating this design is context compaction. As an execution session lengthens, the model summarizes conversational history and file references to save space. Text-based task lists inevitably get generalized and forgotten. Claude Code bypasses this entirely using its built-in live task list, driven by structured native tools like Task Create and Task Update. Because this list exists as internal tool payloads, its exact state remains strictly immune to context compaction. You never configure this manually. Claude activates these task tools autonomously the moment it detects a multi-step operation. To check the hidden state of the build, you query the agent in plain English. You simply ask, what is left on the task list? The live task list guarantees the agent maintains perfect short-term memory of its progress, operating without burning through your context limits. The live task list is highly efficient, but it is entirely ephemeral. It evaporates the second you close the terminal or clear the session. Preserving state across days or teammates requires a durable cross-session mirror. Doing this correctly relies on a firm rule of data architecture. You never force a single file to serve both machine parsing and human readability. On the left, a strict todos.json file holds a machine-readable array of IDs and timestamps matching the LLM's internal schema. Arrows flow continuously from this JSON through a parsing filter, automatically updating a rendered, visually clean todo.md file on the right for human engineers. The technical hurdle is keeping the ephemeral live task list synced with the durable JSON tracker without relying on the developer to manually update anything. You solve this by building a custom automation skill, typically named sync todos. Once that skill exists on desk, you wire it to a stop hook within your Claude configuration. The stop hook runs silently at the end of every LLM turn. It grabs the internal state and seamlessly pushes it to the JSON file, catching all manual updates that standard lifecycle events miss. By automating this loop, the system updates its own long-term memory, completely removing the developer from project management chores. With all 4 layers built and isolated, the architecture supports fully autonomous execution. The required starting state is strict. Your specification document is committed to disk, your context window is entirely clear, and your synchronization stop hook is active. This flowchart tracks the final execution cycle. Initiate the loop by setting a completion condition with /goal and enabling auto mode. This acts as a localized supervisor. After every turn, it evaluates the state, continuing execution or triggering an exit once criteria are met. The developer's role shifts entirely. You step away from the machine, allowing the orchestration layer to handle the build logic. A successful run can last hours and execute dozens of turns. It ends with a terminal report verifying that the goal is achieved and all acceptance criteria are passing. Spec-Driven development is the strict architectural framework required to upgrade a local LLM from a fragile code generator into a relentless feature builder.
The conversation has wandered through 6 detours, and you cannot remember which acceptance criteria still fail. Do you reach for an Spec-Driven development plugin? Do you get the latest project management plugin? Before you reach for one of those discipline frameworks, there is the uncomfortable truth. None of these plugins are necessary. Claude Code already ships the planning, the written record, and the live progress tracker. Claude Code calls them tasks and task lists, and they are part of the planning phase. Your sessions fall apart, not because the tool lacks project management. They fall apart because nobody told you which layers it already includes. This chapter is the missing manual. Later, you will try a TODO.md first and try to understand what Claude Code already provides. We will cover how to prevent the need to keep nagging the Claude Code to update the TODO.md. Project tracking in Claude Code has 4 layers. Each does exactly one job. The mistake almost everyone makes is forcing a single layer to do all 4, then concluding the tool is weak. It is not weak. It is layered. Plan mode is read-only research that ends in a proposed plan that consists of a task list. Out S. This plan and task list lives in the session and evaporates when the session ends. Spec.md is the agreed approach committed to the repo at docs/spec/featurename.md. It is durable but static. The task list is the live working checklist. It runs in session and, crucially, survives context compaction. The .claude/todos.json plus todo.md pair is the durable mirror, machine readable and human readable, kept current by a small skill and hook. You want all 4, each pulling its own weight. The discipline is refusing to ask any one of them to be the others. You can store your plans as specs and designs under ./docs/plans. Let's master what Claude Code provides, and then later you can decide if you want to use tools like GSD, Superpowers, or BMAD. Let's look at these 4 layers as a mind map. Plan mode at the top, fast and ephemeral. Spec.md, durable but frozen. The task list live but trapped in the session. You can create a JSON mirror outliving every session but going stale the moment you stop syncing it. Note, each layer answers a different question, and the discipline of using each one for its question is what turns Claude Code is bad at building features into Claude Code ships features overnight. None of this is hidden. None of it needs a plugin. All of it is sitting on disk waiting for you to wire it together. Note, the end game here is to come up with a persistent plan, ensure you have proper validation and verification, then set a goal and let Claude loop through. This is the highest leverage pattern in the whole planning toolkit, and it comes straight from Anthropic's official best practices documentation. For any feature bigger than an afternoon, this is where you start. The prompt template, almost verbatim, says, I want to build something. Interview me in detail using the Ask User Question tool. Ask about technical implementation, UI and UX, edge cases, concerns, and trade-offs. Do not ask obvious questions. Dig into the hard parts. Keep interviewing until we have covered everything. Then write a complete spec to docs/spec/featurename.md. Paste that into a fresh session with whatever rough brief you have. The Ask User Question tool gives Claude a structured way to interview you. Not what is the deadline, but the hard questions that you have not thought through yet. These are the questions a senior engineer asks in a design review, except you are getting them now before the first line of code, instead of in a postmortem. Should the OAuth refresh flow happen invisibly or be surfaced to the user? Do you need multiple identity providers per account? or just one? R. When the access token expires mid-request, do you retry once or fail loudly? 10 to 20 minutes of interview later, Claude writes a complete spec to disk. Open it, read it, fix anything wrong, commit it. The spec is the deliverable of the planning phase, full stop. A typical spec from this workflow has a problem statement, goals and non-goals, proposed approach, considered alternatives, acceptance criteria, and open questions. You do not have to request the format. Claude Planning defaults to this mode. And let's examine, is the workflow drawn as a sequence diagram? Research. Claude interviews you, asks the hard questions, and writes the spec to disk. You read it. Ease, edit, anything wrong, and commit. Then comes the step most people skip, and it matters more than it sounds. Start a fresh session to execute the spec. AOPs. U/clear or open a new terminal. The interview session is full of, we considered X but rejected it because Y detours. Those detours were essential for writing the spec and are pure noise for executing it. A fresh session reading the committed spec from disk is sharper, faster, and produces noticeably better code. The spec becomes a clean handoff between research, Claude, and build. Claude, even though both are technically the same model. Note, some version of Claude Code will clear the sessions automatically and then load and execute the plan. Ensure that this is the current behavior. Not every change earns a full interview round. For the rest, plan mode does the same job in miniature. There are 3 ways in. A. Shift tab cycles the mode until the status bar shows plan. Prefixing a single prompt with /plan runs one prompt in plan mode without changing the session mode. When starting up, you can use Claude -- permission - mode plan starts the whole session in plan mode. In plan mode, Claude reads files and runs exploration commands, but does not touch your source. When the plan is ready, it presents the plan with explicit options to approve and switch into auto mode, accept edits, or keep planning. The 2 power moves are worth memorizing. Control-G edits the plan in your editor before you approve it. The plan is plain markdown. Open it, strike the parts you disagree with, add what is missing, save, then accept. This single keystroke turns plan mode from Claude proposed something into we agreed on something. Most people have never used it. Or you can prompt Claude for changes. AG. Let's examine the decision tree for which planning depth to use. Skip planning and just do it is for trivial edits that need no design. Plan mode is for, I know roughly what I want, propose it. The interview to spec workflow, described earlier, is for, I have a fuzzy goal, help me think it through. The deciding question is whether the design space is mostly resolved or mostly open. The knee-jerk reaction is, use plan mode for the former. Spend the extra 15 minutes on the plan with the interview for the latter. The cost of choosing wrong is asymmetric. Skipping the interview on a fuzzy goal wastes hours. Running the interview on a small change wastes 15 minutes. When in doubt, interview. Another trick while in planning mode is ask Claude to interview you about anything where it is not sure, or call out areas where you want clarification and ask it to interview you further about certain aspects or features. But what about tasks that we decide to delay or add later? Or what about a plan that has many phases? What is the answer to where is the list of to-dos that stays current as we work? Claude Code has had it built in for months. Most people have never opened it. Since version 2.1.142, sessions use structured task tools to maintain a live task list during any non-trivial work. The behavior is identical to the older TODO write shape. Claude spots tasks as it works, creates them, marks them in progress when it starts each one, and completes them as it finishes. It activates on its own when a request needs 3 or more distinct actions, when you hand Claude a list of items, or when the operation is non-trivial enough to benefit from tracking. How do you see the list? The interactive mode docs mention a Control-T toggle, but in practice it is unreliable across terminals. The reliable move is to ask Claude in plain English. Now, show me all tasks. Mark task 3 done. Add a task for the changelog. In, Claude raids with task list and updates with task update. You never need to learn the tool names. Let's look at the task lifecycle as a state diagram. Pending, blocked, in progress, and completed. Note, each task moves through these states whether it lives in the session, in the JSON mirror, or in your tracker. EIS tree. Why does the live task list beat a TODO.md file for in-session work? 3 reasons. The list survives /compact, where file references get summarized away. Claude updates it as part of doing the work, not as a separate ceremony you have to remember. and asking for it gives you a current snapshot, not a stale file. To share one list across sessions, set the shell use code task list ID environment variable when you launch. Same NVVAR, same name list, different session. That is how you carry a task list across work trees or across days. The in-session task list is excellent for where are we right now. It is useless for what should I read Monday morning. For that, you want a durable file in the repo, and the pattern that works keeps two files, one for machines and one for humans. .claude/todos.json is the machine-readable mirror of the task list. Same shape as the task tool's internal state. Easy to read programmatically, easy to diff, easy to merge when two collaborators touch it. TODO.md at the repo root is the human-readable rendering generated from the JSON. This is what you actually open with Coffee, pretty markdown, organized by workstream, with each item's status legible at a glance. Why two files? Because the audiences want opposite things. A machine wants stable IDs and structured statuses. A human wants headers, checkboxes, and dates. One file serving both means doing one job badly. You can just ask Claude Code to write your tasks to a JSON mirror called todo.json that survives sessions and can be checked in to Git. You can ask it to read these on session start with a hook or create a skill to persist and read tasks. I often ask Claude Code to capture items it deems out of scope for the current plan into this task list and mark it as future. Then I have a skill that can read this and keep track or even sync it to Jira or GitHub issues. You can automate and force the persistence of the task list with skills and hooks, which we will cover later. Shape of .claude/todos.json trimmed to the essentials, a version field, an updated @timestamp, and a list of to-dos. Each to-do carries an ID, a subject line, a status, an active form for present tense rendering, a workstream tag for grouping, and a blocked by list for dependencies. The full listing in the polished chapter has the description field, the blocks list, and timestamps for created and completed times. The fields are exactly the ones the task tools use internally, plus the workstream tag for grouping in the rendered view. This is what makes the sync trivial. The in-session state and the on-disk state have the same shape, so the skill just reads one and writes the other. Let's explain the sync architecture as a flowchart. Work happens, the task list updates live in the session. A stop hook fires after every turn. The hook runs the sync todos skill, which reads the live task list with task list, merges it with .claude/todos.json, writes the JSON back, and regenerates. TODO.md from the JSON. One source of truth feeds three views, the JSON for tooling, the markdown for the dev team, and an optional public TODO for stakeholders. You build the skill first because it is useful on its own. Then, you add the hook second because the hook only matters once the skill works. The stop hook is one config block, catches everything that changed in the turn, and saves you from ever remembering to sync. This is just as an example. Instead, you could sync tasks to Jira or GitHub or do both. Or you could use the tasks as built-in items and use them as they are. This is just to show that Claude already has a task system as part of the planning. It uses this to keep on track. Let's look at this example hook file. This is the stop hook config in full. It lives in .claude/settings.json. After every Claude turn finishes, the hook fires. The hook type is prompt, which means Claude actually invokes the skill. The prompt body says, use the sync to-dos skill to update the JSON and the markdown from the current task list, and do not modify any other files. This is it. You never have to remember to sync. Let's cover two production notes. This skill needs write and edit permissions for the two file paths. If write is an as, the hook stalls waiting for approval, so pre-approve writes to those two paths. Then commit both files to version control. The point of a durable mirror is that the team can read it. This only works if it is in the repo. Note, you don't need the hook to use tasks. This is just an example to show that you could keep them in sync. point. This is where the spec workflow earns its keep. With auto mode and /goal, you hand Claude a spec and walk away. The full flow for a real feature has 5 steps. First, run the interview prompt and land a spec on disk. Commit it. Second, /clear or open a new terminal. Reset the context. Third, set the goal with one command. Implement the spec in this path until all acceptance criteria hold and the test suite passes. /goal sets a completion condition. After every turn, a small fast model checks whether the condition is met. If not, Claude starts another turn instead of returning control. If yes, the goal clears and Claude reports done. Ect T. Fourth, Shift Tab to Auto Mode. The Auto Mode approves tool calls within a turn using a classifier so saved tools get auto-accepted. The slash goal decides when to stop. Theo. Fifth, Walk away. Get coffee. Come back to a finished feature and a clean task list. After the entire loop is done, the worked run finishes with a clear report. Goal achieved in 2 hours and 14 minutes, 47 turns. Note, all 8 acceptance criteria from the SPEC verified, and all 132 tests pass, 0 failing. See that you wrote 1 prompt to start the interview and 1 prompt to start execution. Everything else happened while you were elsewhere. This is the workflow that project management overlays like GSD and Superpower and BMAD were always trying to give you, except every layer is native to Claude Code. The spec is a committed markdown file. The goal is a one-line command. The autonomy is built in. The progress is in .claude/todos.json and TODO.md, both in version control. The work is shipped before you even look at it. The moral of this story is that you should learn what Claude Code provides before you adopt other tools. It is not saying you should not use these tools. For multi-week or shared work, a few habits matter. Commit the SPEC. It is the source of truth for what you are building, and the answer to why does this work the way it does? 6 months later. Commit both .claude/todos.json and TODO.md. With the hook wired, pull requests that touch one will touch both. If your team already lives on a Tracker, Linear, GitHub Issues, or Jira, use the relevant MCP server instead of the local JSON or both. I often add a ticket number or label to tasks that have mirrors in Jira or GitHub Issues. This is the same idea, different storage. Claude reads the tracker, proposes work, moves issues to in progress, and posts results back. Solo projects do fine with the local JSON. Multi-person teams probably want everything centralized in the tracker they already have. For visibility across parallel work, Claude Agent shows every Claude Code session on your machine, running, blocked on you, or done. Pick a project that has been sitting half-finished and do exactly this. First, run the interview prompt against the next feature on the list. Use the Ask User Question template verbatim, or better yet, turn that prompt into a skill. Ask South C. Let Claude interview you for 15 minutes. Second, read the spec it writes to docs/specs/featurename.md. Edit what is wrong. Commit it. Third, start a fresh session with /clear. Set /goal against the committed SPEC. Switch to auto mode with Shift Tab. Walk away. Fourth, and this is the part to do before you forget, before the next feature, not after. Build your version of the sync to do's skill and extra bonus points wire the stop hook. Then use the skill creator as skill from the official marketplace if you do not want to handwrite YAML. That is the whole workflow. Everything else in this chapter is what you reach for when this alone is not enough. The reason your AI coding sessions fall apart at hour 3 is not a missing plugin, it is a missing mental model. Claude Code already gives you 4 layers, each doing one job well. Plan mode for what should we do. A spec for what do we agree to. The live task list for where are we now. Booklo, the JSON mirror for where are we across sessions. Wire them together and you get a written record, a live tracker, and a durable backlog without integrating anything. Spec-driven development with Claude Code is not ceremony. It is the difference between asking a tool to write code and asking a collaborator to build a feature. Next time, in part 5, we cover the permission modes and the auto mode subsection that explains why approve stopped being part of my day.